Alright, here's something cool about Python that most people don't think about right away. Not all numbers are the same. Yep, in real life, we kinda treat numbers like one big happy family. But in Python, they've got roles, they've got types, they've got attitude. Depending on what kind of math you're doing, whether you're counting things, measuring something, or working with decimals, Python hands you a different tool for the job. So instead of just saying, here's a number, you've got to be a bit more specific. The two most common types you'll use are int, that's short for integer, and it's what we use for whole numbers. Float, short for floating point, which is a fancy way of saying number with a decimal. And then there's one more, a little more advanced, a little more niche, but still part of the squad. It's called complex, and yes, it's exactly what it sounds like. We'll peek at that one later. So let's break it down and look at each of these number types, what they mean, when to use them, and how they show up in Python. Alright, let's start with the number type that feels the most familiar, good old integers. These are whole numbers, no decimal points, no fractions, just clean, simple, solid numbers. They can be positive like 5, negative like -10, or even 0. And in Python, they are super easy to use. Just type the number. No quotes, no funny symbols. Python gets it. Let's look at some examples. So age equals 12. Makes sense, right? We usually think of age as a full number. No one goes around saying, hey, I'm 12.6 years old, unless they're really into decimals. So we use an integer here. Points equals -5. Maybe you lost 5 points in a game. Yep, integers can be negative too. Python's cool with that. Number of lives remaining equals 0. That's usually game over. But in programming, 0 is just another integer, and it's often used to show that something is empty or done. Riding the decimals wave, floats. Now let's take it up a notch. What if we do want to store numbers with decimal points? That's where floats come in. Floats are numbers that have a decimal part. Even something like 5.0 is not the same as 5 in Python. Because of that 0.0, it's now a float. We use floats when we want to be more precise, when whole numbers just aren't enough. Here are some floaty examples. Price equals 19.99. Classic. Prices almost always have decimal points. If something costs 19 euros and 99 cents, that's a float. Temperature equals -2.5. You'll see decimals a lot when measuring stuff. Weather reports, for example. That freezing cold morning? Definitely a float. Distance equals 5.0. Now here's a fun one. This looks like a whole number, but Python sees the 0 and says, aha, this is a float. That's how we tell Python, hey, this is a measured value. Treat it like a float. A tiny peek behind the scenes. Memory stuff. Okay, now I'm going to mention something you don't need to stress about right now, but I still want you to hear it just once, so the idea is in your head. Behind the scenes, Python stores int and float numbers differently. Integers are simple. They take up less memory and calculations with them are faster. Floats are a bit more complex. Python needs extra space to keep track of both the whole part and the decimal part. So floats use more memory, and math with floats can be a tiny bit slower. Now, in small programs, you probably won't notice any difference. But in bigger apps or when you're handling tons of data, these small decisions can add up. So eventually, you'll start to think not just, does this work, but is this the best way to do it? And don't worry, you don't need to figure all of that out today. Just keep it in the back of your mind. With practice, this kind of thinking will start to come naturally. Okay, so before we wrap up this number party, there's one more number type I want to introduce you to, just so you know it exists. It's called a complex number. Now, unless you're building a rocket, solving physics equations, or trying to simulate electricity flowing through a circuit, you probably won't need this. But hey, it's part of Python and it's cool to know. A complex number has two parts. A real part, just like the numbers we've already used, and an imaginary part. Yeah, imaginary. But don't let the name scare you. In Python, imaginary numbers use the letter J, just like engineers do. So here, 2 is the real part and 3j is the imaginary part. Python lets you access both separately if you ever need them. That's it. You don't have to memorize it or dive deeper right now. Just know it's there if your future self ever needs to do some wild sci-fi level math. Alright, now back to the real world and real numbers, where most of the action happens.